Okay, here we are, starting the session on the writer's brain. And with me is John McConnell and Beth Began, and I thought it'd just be useful to just briefly introduce each of yourselves so that people can get a sense of, like, what your comments and questions might come from. So, Beth, how about you just go first?
Sure. My name is Beth Began, as Mark indicated. I am from Boston, Massachusetts. I met Mark. He was my mentor through a master's program, Master's in Transpersonal Psychology, a few years ago. And I had a wonderful experience with Mark and with the program. And since then, I have been interested in the way the mind-body connection works and different emotional states, especially coupled with the body and the brain. So I do not, unfortunately, at this point, utilize that degree in my professional life. I'm actually in the corporate world, and I work with lots of data and lots of technology partners and business partners to create really smooth running infrastructures. So, but I'm happy to be here and
Great.
look forward to this.
So there's a piece that you left out that I want to bring up because I think it's really integral to this presentation. Beth used to be, I'm guessing no longer, a professional hockey player.
Mark, I'm surprised you remembered that.
Yeah, well, it's a pretty unique it's a pretty unique pursuit.
Yeah.
Yeah.
Yeah. I guess I do often leave that out of my bio, I suppose. I am very active athletically to this day. I spent a good 20-plus years playing competitive ice hockey, mostly at its peak in my early 20s. And I was, this is the timing is sort of synchronistic with the Olympics on and such, but
Right.
I was on the national team for many years, U.S. national team, and it was a profession for all practical purposes. And sometimes I think playing ice hockey every day and training every day was harder than going to work for 8-10 hours a day.
Right. Yeah.
So.
Okay, great. So for me and the writer's brain and narrative medicine, the body part is really important, and we'll discover why as we go forward. John, how about you briefly?
Well, it's interesting to know I have a lot in common with Beth because I played ice hockey when I was 10.
Right.
That's as far as it goes, though. I live on South Whidbey Island with Mark here. And my wife and I run a business where we do life coaching and leadership training. And my interest in these topics comes from really my own lifelong learning. I'm also athletic and kinesthetic and feel like it's been an adventure to learn how to learn, and particularly in our culture and in the way education works.
And it's changing.
And it's changing, yeah. Yeah, so we integrate a lot of somatic psychology in our work and a lot of learning through experience and a lot of experience with animals and nature. So when I think about how the brain works, I'm very much in the question of how we're connected to our own wiring and vitality, but also very much how that relates to how we're connected to each other and to the world around us.
Yeah. And so you also take people trekking all over the world, right?
Yes, I do.
Yeah.
So we did that as a profession and then now integrate some of that into our corporate leadership development work.
Right. So it's the trekking part that I think is really fascinating because, again, you can't trek without taking your body along with you.
That's right. That's right. And that's why we do it. The learning really speeds up because people are having to, you have to be in your body. You have to be in your emotions if you're out for 10 days trekking the Himalaya. You can't just have it be an intellectual exercise.
Right. Okay, so that's John and Beth, and they'll be going through this with us, and I welcome any comments or questions that you have. And there'll be stopping places also, and then we can additionally address questions. So briefly, I just wanted to say how give you the genesis of this presentation. A couple of years ago here on Whidbey, I used to offer a monthly series called Neuropalooza. And each month we would just show a video of a relatively well-known neuroscientist, and then we'd hold discussions afterward, about whatever it is they were presenting. And the woman I did that for contacted me one day, and she'd recently taken a job with the Whidbey Island Writers Association, and she said, "Wouldn't it be great for you to do a presentation on the writer's brain?" And I thought, wow, that would be fun. Simultaneously, a friend of mine who's a professor at Bastyr University contacted me and told me that her son had enrolled in Columbia Medical School in New York, and that he had just taken this great class called Narrative Medicine. And wouldn't it be great for Liz and I to co-present that class at Bastyr, which is a naturopathic college in Seattle? I thought, well, it'd be great to combine both of these, actually, right? So essentially what I'm presenting here is a distillation of the seminar Liz and I are going to be doing. And probably the only thing missing from it is the time that we're going to be giving students to do a lot of writing, right? So the content, much of the content will be the same as Bastyr. Okay, so here we go. We look at this first slide. We're looking at a kind of a psychedelic brain. One of the things I love to do is go scrolling through Google Images for innovative brain images. And so this one really called to me about movement and sports, because I see like baseballs in there, basketballs, and drugs, and all kinds of interesting perspectives. And then I put this quote in here from Ray Bradbury. "And what, you ask, does writing teach us? First and foremost, it reminds us that we're alive, and that is a gift and a privilege, not a right." And so writing teaches us that and much more, as we've come to discover through this process of narrative medicine, creative writing. We look at slide 2, what the presentation's going to be attempting to do. So you can see it on your screen. If you're in full screen mode, remember you have to be in full screen mode to see the animation. We're going to be connecting a lot of dots that aren't generally connected by either writers or neuroscientists or people involved in the creative arts. Okay? And so Beth and John, your job is, if the dots aren't quite connecting for you, just speak up, and I'll do my best to sort of try to make things more clear. All right? And then once the dots are connected, the hope is we'll be producing some kind of coherent, integrated whole, which is what you should be seeing right now on slide 2 as we move forward. All right. The writer's duty is to help man endure by lifting his heart, from William Faulkner. And I think it's also the neuroscientist's duty as well, even though the heart often gets short shrift in neuroscience research, right? All right, so briefly, I wanted to introduce me. Here's a picture of me sitting on a log, although the log you won't see in the picture. I'm an old guy now. And here's me 30 years ago on a biodynamic farm where I was working with emotionally disturbed teenagers. That's me on the left. So I was out in the barn at 5 o'clock one morning, and one of the teenagers was out there with me, and she called my name, and I turned around. She had a camera, and she just snapped a picture just as this cow came over to say good morning. And it's kind of like my favorite picture because it mostly portrays to me what it feels like to be me. All right. And then here's me again. this doesn't very much feel like what it feels like to be me, but it's me at a really critical age, roughly 18 months. All right? You can see sort of the 50s decor and the black and white photos. And so I put this picture in here because what we'll discover during this presentation is that the 18 to 24 month window is a really important window in terms of narrative medicine, in terms of creative writing, in terms of neuroscience. So just to give you some background in terms of me as a writer, I've done 3 novels, 7 nonfiction books. Here's one of the novels. So for those of you who don't know, psychomantium is a process that was done in ancient Greece to prepare people to visit with the oracles. And what it involves is basically sitting in a dark room with a mirror tilted away from you and staring at it until you begin to have hallucinations. And often the hallucinations you'll begin to have show up as important people in your life who've died. All right? So research around psychomantium right now is involved trying to use it to help people move through complex grief. All right, so that's one. The next one is Death School, which is a story about a teacher who discovers that we don't really educate people for what I call good at the end in this culture. And so he starts a school to teach people how to die. All right. And then the third one was called The Icing of the Shooter. And this was a novel that I'll tell you more about as we go forward. All right. And mostly I wrote these because I just love to write and wanted to learn to perfect the actual craft of novel writing, creative writing, and tell a good story, right? And then finally, I write the Flowering Brain Social Neuroscience blog once a week, every Sunday. And I use this as a way to help me organize my thinking, because what I know about how the brain works is that if I'm going out and trying to learn things in order to teach them to other people, it really helps me organize both my thinking and discovering, going out and searching and discovering the things that I'm really interested in learning. And that actually has a name. It's called the protege effect. All right. Okay. So I help make social neuroscience make sense, which is what I hope I'm doing right here. Okay. So the way I like to organize these presentations is just to basically think about the questions I would want to have answered if I were you out there attending, right? But because I've researched this topic a lot longer than you, many of you probably wouldn't know to ask these questions, so I'm asking them for you, all right? And I'm not going to go through them right now except to post them up here to show you how we've organized the morning. All right. 12 questions. The last one I think is probably most interesting, and I've gotten a lot of flack for even putting it on here already. That's okay. All right, so we're going to go through question by question. And if we look at slide 9, what we see is what I put up here about narrative medicine and creative writing. And that's we just need to do one general thing. And it is learn to recognize and understand the language of our body. And that's a big thing. And it's certainly been a big thing for me to come to understand. And I'm still in the process of learning how to do it more effectively and more skillfully. All right, other parts. So the body has a brain, In slide 10, we see some of the pieces for those of you who aren't familiar with it. Basically, 4 lobes, parietal, frontal, occipital, and temporal. That's the outer covering of the brain. And then the brainstem, the pons, and the medulla oblongata. And then the limbic system inside the brain. So the cortex covers all these interior structures. And these interior structures are mostly connected with feeling. All right? The outside structures are mostly for processing sensory information. But again, this is a system, right? There's 86 billion neurons in this structure, and they're all wired together, right? In this enormous complexity. You haven't even if you watch the Jeff Lichtman video, you know, he indicates that we are about 3 inches along on a mile-long journey. So this is a baby science, right? But we know enough, it's my sense, that we know enough to actually begin to help people think about and organize experience and health and well-being. All right, so there's one more piece on here. I put a red arrow. Should be showing up there momentarily. And this is a critical piece of the brain. And you won't find much out there about it because it's new research, all right? So I mentioned there's 86 billion neurons in this whole structure. Of the 86 billion, 69 billion of them are contained in the cerebellum. This is really important from my perspective. So this is another reason why you won't find a lot of information out there about this research is because it wasn't done in America. It was done in South America and another reason you won't find information about it is done by a woman neuroscientist. Her name is Susanna Herculano Houzel, and she basically was curious about how the neuroscience community came up with this number of 100 billion neurons, which has been the standard for many years. And that's a big number. How do you actually figure that out? So she went to the literature and couldn't find any base reference. Everybody was referencing someone else, but she couldn't find the original, reference and how they actually determined that number. So she said, well, I'm a neuroscientist. I can figure it out. And so she developed a process using her creative brain called isotonic fractionation, which essentially is able to boil all these structures down into cell bodies, right? She made what she calls a brain bisque. And then she just took a sample of the remaining cell bodies. It got rid of all the fat and all the extensions, dendrites and axons that come off the cells. And she took a portion of the bisque and she actually did a physical count of the neurons, cell bodies that were remaining. And what she came up with 86 billion, right? Well, it's pretty close to 100, but then she did a separate count of the cerebellum and came up with 69 billion. So that means that somewhere between 80 and 90% of the cells in the body, in the brain, have to do with physical movement. And there's a Cambridge neuroscientist, Daniel Walpert, who recently did a TED Talk, and he argues this very same thing, that the brain is basically designed, first and foremost, to move the body. All right? Why is this important? Well, it's important for a lot of reasons. In terms of narrative medicine, much of what happens to us in our young lives and even before we're born that involves some kind of restriction to physical movement disorganizes the brain's function, right? So we're going to go a little more into that. Reading or writing a novel actually changes many of the structures in our brain. And you can actually feel this when you get totally engrossed in some writing. You can actually feel, senses of excitement, pleasure, fear, stress, anxiety as you're reading and as you're writing. Okay? So here's another piece to remember, and that is the brain is constantly changing. Everything changes the brain. Being on this call changes your brain. And on my blog, I posted links to videos that actually show those cells moving constantly, seeking connection and disconnecting, finding new routes to different areas and hooking up in different ways. And it's just fascinating. And we're sort of like just now learning how dynamic and active this structure is. And the reason we haven't figured that out until recently is because most of the research was done on dead brains, dead human brains for many, many years. But now with technology, we can actually do a lot of research on living brains. All right, looking at slide 11. In addition to what they can see, taste, touch, and hear, writers are well served by increasing what they can feel. Okay? So here's a chart that was put together by some folks in, I think it was Finland. And what they discovered are that the body registers all these different ways of feeling in terms of its capacity to express and generate energy. And so what's interesting to me on this particular slide, and especially for writing and reading, are the two conditions that generate the most energy. Happiness up at the top in the middle, and love, second in from the bottom on the left. And I don't know about you guys, Beth and John, but this certainly matches my experience. How about yours?
And then I want to ask a question here. Is this self-reported? Like, is this internal data, or is there some way they're measuring this externally?
It's self-reported by a large cohort.
Yeah.
Yeah. Yeah.
Yeah, I would agree, Mark. It's quite startling how accurate it is across the spectrum, not just with happiness and love, but
yeah, absolutely. I mean, when you look at depression, that makes like total sense. You've got no energy going on, right? All right. So feelings turn out to be a fundamentally important component of meaning. We can't make meaning in our lives unless we're able to feel things. And so the best creative writing, in my experience, the things that I found to be most powerful in my own explorations, were the things that I felt most deeply. Okay? So in addition to what we can taste, touch, smell, and hear, writers are well served by what they can feel. So this is one of my recent brain image acquisitions of the reptilian brain. And it's often the reptilian brain that is the first feeler, right? Because the brain is exquisitely attuned, and the body are exquisitely attuned to threat in the environment. It's constantly monitoring the environment for threat, and it doesn't tell us that it's doing that, right? Except if we're paying attention to our body. All right. So this is going to come up later, why that's important. So the creative writer's primal neural directive, we look at slide 12, is to look at our senses and how they operate. So this is really interesting research from my perspective. the perspective, I think, of writing and narrative medicine. And that is a group of researchers got together and they did an assessment of just how much information our senses can take in at any moment. And it turns out that they could come up with a quantifiable number, which I thought was really interesting. And in artificial intelligence communities and in cybernetic research, these numbers are pretty much subscribed to by researchers. And even if they're wrong, here's the important part, even if they're wrong, the ratios are what's really important here in terms of the total bandwidth our senses take in relation to how much it takes in consciously. All right? So here they are, 10 million for the eyes, 100,000 bits of information for the nose, 1,000 for the tongue, mouth, taste, 100,000 for the ear, 1 million for the sense of touch. All right? So that's that's total. And then of that total, look at how little we're actually able to take in consciously in any second. All right? So this turns out to be roughly, it's less than 1%. And what's confounding and surprising to me, and I'm guessing that every one of you, is that when I look out my window here, and it looks like I can see so much. It's hard to believe that of 10 million bits of information coming in, I'm only seeing 40, right? But all you have to do is take some drugs, take some, entheogens, and they will totally transform what you're able to see, hear, taste, touch, and smell, because they change the brain's capacity to process energy and information. So what I'm arguing for here is that creative writers, through the process of beginning to explore their sensory experience and their feeling experience through the body, if you only increased your capacity by 1%, you would double it. And you'd be operating in the world at a tremendously enhanced ability compared to the population as a whole. Does that make sense to you guys?
It wouldn't hurt for me to hear that one more time.
Okay, so here, let me see if I can clarify. So basically, we have these 5 senses. Our experience, our daily experience of using these senses seems like we take in a tremendous amount of information. But what we don't realize is just how little the amount of information we're actually taking in is. Okay? And so John, I'm guessing when people go on, a trip with you to Patagonia or wherever, their senses become enhanced significantly because they're in time out of time. Presumably they're in an environment that you're making really safe. They're seeing and tasting and touching and feeling all kinds of new things they haven't ever experienced before. Is that true?
Yep.
Yeah.
Yeah, and then you said earlier, and then the so what of that in terms of implications as you see it here is?
Well, the so what is, first of all, being aware of just how little we actually do take in, and then coming to recognize that we have the capacity to increase conscious bandwidth.
Yeah, that's where I was thinking, Mark, is how, talking about we've got all this unconscious stuff going on, right? And how do we work towards making that conscious?
Right. Okay. That's exactly what this presentation is hopefully going to connect dots for you around. But first of all, we have to recognize this condition in ourselves, right?
Mm-hmm.
I mean, it just blew my mind when I was reading a book I read was, what was it? The Self-Illusion by Bruce Hood, where he first mentioned this. You know, he's a Harvard neuroscientist, and I said, that can't be true. And I actually went and looked up this Zimmerman study because I just wanted to see exactly what they're talking about. How could this be true? And then I remember many of you on the call are familiar with Ram Dass. I remember in an interview, someone asked him a question about his use of drugs, psychedelics, during the 60s, if he felt like that was useful to him. And what he said, well, what it did is it opened up my mind to the reality of just how little awareness I was walking through the world with. And subsequent to those drug experiences, the rest of my life has been devoted to trying to integrate what I actually experienced without the use of drugs, right? Because drugs only provide a momentary glimpse of the possibilities, but you can't sustain them unless you have a foundation that will allow you to actually do that. And there have been people on the planet that we have discovered or encountered and left writings behind talking about, reaching these states of integration and awareness.
Mark, I have a question.
Yeah, Beth.
Where does all the information get stored? The 10 million, 100,000, etc.
Yeah.
The body, the brain, both?
Well, that's a great question. And what I can tell you is whatever I tell you, we'll probably discover is only partially true or completely wrong. So, for example, it's generally considered that this structure in the brain called the hippocampus is the seat of memory. And Eric Kandel won the Nobel Prize for discovering how memory actually works. And the way he discovered it was by studying the California sea snail for 30 years. They have the California plesia has essentially 2 neurons that are visible to the naked eye. So he could do all these interesting experiments to figure out how memory works. And basically how memory seems to work is we grow new connections with experience. So you listening to this call right now is actually growing offshoots in your neural network that are connecting to things you already know and are beginning to grow new fibers for things you don't know. Does that make sense?
Yep.
So this is a living network, right? A dynamic, powerful living. It's sort of like the internet, but alive and constantly morphing. All right. So here's a recent study I just found this week, done by Gregory Burns at Emory University. And essentially what he did is he put people in a scanner and had them read a novel. And what he discovered is that these different areas begin to make all kinds of new connections in the brain. And he could actually see them inside the scanner, right? Well, if reading a novel can result in increasing these connections, I would hypothesize that writing a novel increases these connections even more, because that's been my experience, right? Reading a novel allows me to immerse myself in the writer's world. Writing a novel actually has me create the world I'm inhabiting. And that has good effects and bad effects, as we'll discover going forward. All right. So again, I mean, this is a really dynamic, living, pulsating, constantly changing network, collection of cells that live inside our head and extend into the body, as we'll see coming up. So the writer's brain, slide 14. I put this slide in here to show you essentially a list of human defenses. And the way I think about human defenses are essentially parts of the brain that inhibit activation, inhibit neurons from firing. Right? They close down the flow of energy and information by necessity. You know, when I was studying to become a therapist, one of the rules that we had was you never deliberately take away a person's defenses until they're ready to let them go. Right? And if I think about it in terms of brain development, people become ready to move beyond their defenses when they have grown sufficient neural connectivity and integration where holding on to the defense no longer makes sense. Does that make sense to you guys?
It does. I mean, I hope it's common knowledge that we all have to work with our own defenses, sort of on our own, obviously with support, but we can only get through our defenses through our own, by our own strength and energy.
Yeah, it's our brain and our body that we're working with. Right? Those are the things that we're growing, increasing capacities for and with. I think I've mentioned, probably all of you on the call haven't heard this, but essentially I was traumatized in 7th grade by a history teacher who publicly shamed me. And I didn't speak again in a public classroom for over 10 years because of what that experience actually did to my brain. And it was a revelation to discover that, my inability to be engaged and verbally present in a classroom really wasn't my fault. It was something that happened to my brain. And so then doing the work of being able to come out of it was really a painful struggle. I mean, I got fired from my first 2 teaching jobs because I was terrible. But by practice, by continuing to put myself out there, and by doing the things I needed to do to make it possible to be present without a lot of anxiety and disorganization. I remember my biggest fear was that I would go to a classroom and it would be a 3-hour class, and after 1 hour I'd run out of things to say. That was terrifying to me. And so I would always over-prepare, and I'd have like 4 hours of material. And then one day, I was doing a class, a 3-hour class, and that happened. I somehow ended up with only 1 hour of material. And I did my best to make stuff up and engage people and go for another hour, but then I was done. I couldn't do any more, and I just dismissed the class, and everybody was so happy to get out early. So that was a lesson in integration for me. All right, slide 15. So what are the pluses, 14, what are the pluses and minuses of these defenses that we're holding, right? So there's a saying in the Course in Miracles that I really resonated with the first time I heard it. It says, "In my defenselessness, my safety lies." right? That really resonated with me somehow because I could see that defenses were important, but they were really limiting, mostly in my capacity to deal with present moment reality, right? So what are the pluses and minuses of defenses? And I'm inviting you to hold that question, and we'll see going forward what some of them might be. Slide 15, how does the brain do what it does? So I put this slide in here because I really want you to understand that both the elegance and the simplicity that about how the brain works that results in this enormous complexity. So basically we have 86 billions of these little cells at the top, these blue pieces with the cell body on the left and this long wire that runs down. And the wire runs down and makes connections to all the other 86 billions. Not all of them at once, and not all of them together, but some portion of them, right? So the optical nerves at the back of your eye run through your skull, run wires through your skull, and connect up at the visual cortex at the back of your brain. And that's how it got to be identified. That's how actually all those parts got to be identified by the functions they perform based on how the wires run, right? And now these wires, essentially all they do is they generate an electrical charge. So it's really useful to think of the brain as containing 86 billion little batteries. And how the batteries turn on or off is very simple. These little channels open, sodium pours in, potassium pours out. And when it does, it generates an electrical charge that goes from roughly 50 millivolts, minus 50 millivolts, to plus 70 millivolts. And if we look at the next slide, which is an animation, how every conscious creative human act happens in the world, including establishing and maintaining defenses. All right, so John and Beth, can you see this video operating?
It's just starting for me.
Yeah.
It's a little glitchy, but it's going.
Yeah, so you can see K is potassium. You can see the channels. Some of them are specifically designed only for sodium. Some are specifically designed only for potassium. And some, the blue ones on the left are open, and they open and close depending on the voltage going through at the bottom there. You can see peak rising and falling. So this is basically how the brain works. You see at the top, you see these wires coming down, four of them together, generating this charge that hits a cell, and then that electrical charge continues down the line. So this is how we think, this is how we move the body, this is how we speak. It's involved in everything we do that's human. This simple little process, right? Now, here's where it gets really interesting. If you look at those four axons, the wires coming down, touching the one cell, they're all generating a charge, right? Well, some of the cells in the brain have wires coming down that actually inhibit a charge, right? They don't all work to make the action potential propagate. Some of them make it not propagate. And that's what we're going to explore in terms of creative writing and narrative medicine. So at this point, I want to talk just briefly about writer's block. All right. It's a topic that a lot of people have questions about. Essentially, writing is a motor act. It's a physical act. We have to move our hand, whether it's with a pencil or pen, one hand, or whether it's two hands on a typewriter. And so for many of you, I'm guessing that the experience of writing with one hand or with a pencil or pen or on a typewriter are qualitatively different. That's at least my experience. And that makes sense because when you're writing with two hands, you're basically employing neurons from both sides of the brain. And when you're writing with one hand, usually your preferred hand, you're only activating neurons on one side of the brain. So one of the interesting experiments to do in terms of writing with one hand is to use your non-preferred hand and just see what the difference turns out to be. For many people, it's a significant difference, right? So in terms of writer's block, most people who experience writer's block don't have any motor difficulties. They can actually move their hands. So if it's not a motor problem, and the action potentials are available to fire in order to move our hand, then what keeps us from being able to write? Well, it's something else, right? And it's something else that's generated in the brain that has nothing to do with being able to put words on paper or on, a computer file. So we'll see more about what that is going forward here. All right. So you saw the Jeff Lichtman video. These underlined pieces. If you click on them while you're in full screen mode, they're actually hyperlinks that will take you directly to the presentation there. But we're not going to do that here. All right. Slide 17. So here's a quote from Jeff Lebowski, from The Dude. New shit has come to light. So when new shit comes to light, it's really important for us to be able to find ways to actually pay attention to it and incorporate it into our lives. And so part of what I love about neuroscience is that new shit is coming to light all the time. There's 40,000 papers published a year in neuroscience. Like, there's no way anybody could read all those. All right, so here's how the brain develops. And I found this to be really interesting in that it doesn't develop uniformly, and it doesn't it doesn't continue to develop uniformly in my experience, even beyond the 12 years shown here. As I look back through my life, I can see that there were periods in my life when, I was wanting to engage in what are characteristically thought of as left brain activities, more cognitive, more linear and logical activities, and other times when I wanted to, be involved in more creative activities. And that's basically how I came to spend time, writing novels and sort of like recognizing and honoring that impulse. And fortunately, I was able to do that. And at some point, it'd be great to hear if this sort of pulsating developmental model has been operating in you folks' lives as well. Okay, so if we look at, we keep clicking through on slide 17, what we see, we ask this question, what happened here? Well, something really significant happened here for most of us, and that is the window opened for acquiring language, right? 18 to 24 months is when the language window opens. But prior to the language window opening, learning has been going on from long before birth, basically from the time the first synapses are firing in the brain. Learning starts happening. And so from some period in utero up through the acquisition of language, what's happening is learning is going on, but it's not but it's learning through sensory experience. It's learning through the body. So if the pregnancy is an especially stressful one, the brain of baby is learning what stress feels like in its body, because baby feels mother stress. Right? What we also hypothesize is that because brains love novelty, while the baby's developing in utero, it's constantly looking for novelty to spur growth. Unfortunately, there's not a lot of novelty in there, but what there is something it can pay attention to, and that is mother's voice. A French ear, nose, and throat doctor named Alfred Tomatis wrote a book called The Conscious Ear, and he believes that it's mother's voice that's the primary driver of neural development in utero. And I tend to agree with him. Actually, it makes total sense to me. Because when infants come out of the womb, they've done experiments where they'll bring mom into a nursery and they'll have her speak, and whichever baby belongs to her will immediately orient to mom's voice. And I remember once, well, I won't tell the story, but basically my experience is that mom's voice has inordinate power for children. Right? They really attend to not only mom's voice, but mom's general emotional affect constantly. So if you look at this developmental picture, what you see is that initially development happens on the right side. And Alan Shore at UCLA, who's identified as the Einstein of attachment research, he believes that because of the way this brain is structured to develop, most traumatic memories get stored on the right side. And they get stored on the right side as something psychiatrists call the unthought known. So what the unthought known is are thoughts knowledge that we have that we can't give words to, right? Feeling states. Undifferentiated anxiety often shows up for people who have no reason to be anxious, except that they had to go through this period of development in their lives. So this is unconscious. This lives in our brain, memories, before we acquired language, that we know but we can't say. So how do we heal? How do we integrate something like this? Well, one of the ways that we're learning to do it, I believe, is through creative writing, through narrative medicine, right? Paying attention to feelings and sensations that arise in our body and giving words to them. Because I believe that process is an integrative process, similar to what happens at night when we dream and have rapid eye movements. One theory about rapid eye movements is that there's actual physical movement of neuron axons across the hemispheres to bring integration, to make connections from left hemisphere to right hemisphere and right hemisphere back to the left hemisphere. Okay? So the unthought known essentially lives in all of us, and we don't know it, and we don't have words for it. So part of creative writing and narrative medicine is to begin to put words to feelings and sensations. Does that make sense?
It makes total sense to me, Mark.
Yeah. Here's David Bainbridge. He's another English neuroscientist. I love the way he describes. He's basically describing the right hemisphere of the brain. The modern geography of the brain has a deliciously antiquated feel to it, rather like a medieval map with the known world encircled by terra incognita where monsters roam. This is what often makes creative writing such a challenge. And for those of you who had a chance to read the blog I'll be posting in a few weeks about William Styron's experience, this makes total sense that he would, write these really emotionally overwhelming books and then not have processed them through his body and end up feeling depressed. Right? The body keeps the score and the brain maintains a record. Unfortunately, the score it keeps and the record it maintains aren't often fully conscious to us. Right? We only get inklings and glimpses. So let's look at slide 18. And you can see in slide 18 just basically what the wiring looks like through a digital tensor imaging scan. The green wires are speech and language areas, and you can see how they thread throughout the hemispheres. And you can't really see it in this depiction, but they also go across hemispheres. And so the vertical extensions are pyramidal neurons going from the emotional structures up to the cortical structures, the outside part of the brain. And so this is a picture of these wires running all through the brain, right? But what's not being depicted here is how all of these wires run down and connect to the body. And we'll see a slide where that happens in a bit. All right. So here's one of my favorite quotes from the Gospel of St. Thomas, reportedly attributed to Jesus. If you bring forth what is within you, what you have within you will save you. If you do not bring forth what is within you, what you have within you will destroy you. Okay, so in my little book called Right Listening, on page 53, I have this story. It's a short story that I want to read right now. It's from Christine Hibbard, who's a psychological anthropologist at the University of Colorado. And so the story goes like this. What is it you're not saying? I had a fascinating experience with a highly balanced masculine and feminine culture 2 years ago in New Zealand while traveling with a group of women healers. We had been invited to visit a sacred reservation-like community of the Maori Polynesian culture. At a gathering of hundreds of men, women, and children, I asked the community's medical doctor just what medicine he used for healing many of the illnesses on the island, and his reply changed my thinking. He said they used no medicines whatsoever, none. If a person was sick in any way, from a cold to cancer, they would call the entire community together and all gather round, including the children. They'd position the ill person in the center, and the community would sit. This physician would ask the person one question, and one question only. What is it that you're not saying? They would all sit and wait for days until this person revealed all of what he or she was keeping to him or herself. The doctor reported a 98% healing rate. They were using their own innate wisdom, their own inner guidance, and the power of full self-expression, that is, emotional truth, intellectual truth, and its interconnectedness. So that's a pretty radical departure from the way medicine's practiced in this country, right? And when I think about this story in terms of neuroscience, particularly social neuroscience, what she's describing is how other people in a community can help us integrate dissociated parts of our brains that are walled off from conscious awareness. Does that make sense?
Yes, to me.
It's a little overwhelming, actually, as I think about it and ponder it. So, if that potential is there, how do we begin to access it? Okay, we look at slide 19. To more creative writing into narrative medicine, we need to do one general thing. So this is a slide we've seen before, only I'm refining it this time. Instead of just talking about the whole body, I'm refining it to say we need to learn to recognize and understand not the language of our body, but the language of our hollow organs. Why do I say that? All right, let's look at slide 20. And this comes from something called polyvagal theory. I've written a lot about it on the blog because I find it's mostly researched by a gentleman named Steve Porges, who's a biophysicist at University of Illinois. And he's talking about the 10th cranial nerve, which is the vagus nerve. And it's a bundle of nerves that comes out of the base of the brain. It doesn't go through the spine. It comes out of the base of the brain, and it goes down. If you keep clicking on slide 20, it goes down, and you'll see it touch every single hollow organ in our body. The amazing vagus. When I first discovered that I had this nerve, I didn't really know much about biology when I started exploring this. When I first discovered that I had these nerve bundles, I was astonished, right? It's like, wow, you mean to tell me that all my organs are constantly in touch with my brain and I have very little awareness of it? Well, it turns out that's true. And it turns out that the vagus nerve bundles are mostly sensory nerves, meaning that they take information from all our hollow organs and they send it to the brain. And so it becomes possible, and I know a number of people who've learned how to actually increase the language that our hollow organs speak to a really refined degree. It's kind of astonishing to be able to gain subtle impulses from the stomach, the heart, the spleen, the liver, kidneys, and to translate what they feel, what information they're receiving, into ways they need to operate in their lives. And a number of people actually take the message they get from their hollow organs and end up moving to Whidbey Island.
Where is it, Mark?
Yeah, it happen to you.
How do we get there?
It's in Puget Sound. It's in the Pacific Northwest, outside Seattle. And there's a lot of neighboring islands that people move to, too. Okay, and it's one of the reasons I moved here, actually, because it feels safe to my body. Until I actually moved here, I never realized the level of stress and tension that was in my body just having to lock the house at night, to lock the car, right? To be constantly vigilant for where threats in the world might show up. Right? That takes a toll on energy and on awareness. And I mean, the first restaurant I went into here, and I walked in, I saw all these laptop computers sitting on tables completely unattended. I thought, wow, if I did that in the Bay Area where I live, that thing would be gone in, 10 seconds flat. All right. So this is polyvagal theory. Polyvagal theory basically says our sense organs have enormous potential to tell us important things about the world and about our general state, right? And Steve calls this neuroception. It's the body's ability to detect threats and not tell you that it's detecting them, except indirectly, if you're paying attention, right? It's also called things like flow and hyper intuition. Here's what Doug Baker calls it. He calls it, the vagus nerve holds the psychological key to superconscious experience. This 10th cranial nerve serves as woman's psychic antenna. It's a way that we can take in information without even being aware that we're receiving it. All right, let's see here. Questions at this point? Beth or John?
I guess I would ask Mark to add how that last point about the vagus nerve, how it possibly connects to muscles, because, if you're getting signals perhaps from the organs that you don't know, and it may result in the muscles, your muscles tensing. What are the thoughts on, the relationship between the brain and muscles, given the relationship between the hollow organs and the brain?
Yeah, great question. So basically, my perspective is that what all of our work is to increase our brain's capacity to process energy and information, right? And so as we begin to do the work that results in increased ability to process energy and information, the things that we're able to attend to and pay close attention to, it's just like learning to play ice hockey, right? Initially, you're clumsy and you can't stand up well, and by repeatedly practicing, you become better and better at it. And as you become better and better at it, you begin to feel really good doing it, right? I'm not an ice hockey player, so I'm just guessing that's what the process is like. Good. Yeah, right. The better you get at it, you actually start triggering pleasure centers in the brain that make you want to do it even more, right? Well, in terms of how this operates in the body with hollow organs and muscles, as we begin to pay and increasing attention to these kinds of things, we'll be very clumsy and make lots of mistakes and not be able to recognize the messages that are being sent by muscles and brain and hollow organs. But as we increase our capacities in this regard, it's like trying to learn French or Spanish or Chinese, right? As we increase our capacity to learn this language, we become able to be much more aware and discriminating, and it becomes effortless. So I don't think that exactly answered your question, and I realize as I'm speaking that I haven't explored the actual role that muscle information feedback might play. My guess is that it's similar, right? If I'm feeling tension in a muscle, it's trying to get my attention, right? Because we don't want to overwork muscles to the point of damaging them. Does that make sense?
It does.
Yeah. But again, it's coming back to this really important piece to recognize that the body is an integral part that needs our, I was going to say attention, but mostly it feels like it needs our protection and friendship.
I think that's a really powerful message, Mark.
Yeah. Befriending our body. Because it's doing the best it can based upon how it's developed over time, based on the environments it's had to function in, right? And environment is key to how we develop, if we look at slide 22, this energy and information processing network. So this is like an ideal network, right? It's got no disorganization in it. It's uniform. It's connected up well. You know, there's the blue cerebellum just cranking out action potentials. You know, this gracefully moving us through the world, constantly and effortlessly aware of our environment. This is probably the ideal. I don't think anybody on this call or probably even in the world has a network like this. But I love the image because it holds so much possibility and potential, right? So slide 23 introduces categories of attachment. And basically what attachment is how our brains develop and the state and level of integration versus disorganization. So secure attachment would represent the most integrated state for children growing up. Disorganized attachment is the most damaged state. Disorganized kids have the least integrated brain that has the hardest ability to process energy information. So this is a big field of research. This research has been going on for 30 years, but it hasn't really been, except for Dan Siegel most recently and Alan Shore most recently, it hasn't really been connected to neuroscience. But now it is. So if we look at the writer's brain, or look at any person's brain, we look at our own personal history, what we discover is this thing called ACEs. ACEs stands for Adverse Childhood Experiences. And it's come out of research that two doctors did, one with the Center for Disease Control, Rob Anda, and another from Kaiser Permanente, working together, Vince Folletti, and their job was to help patients lose weight. Because Kaiser recognized that, wow, you know, being overweight correlates with all these medical conditions that, you know, if our patients didn't have them, they'd never be showing up at our hospitals, and they'd still be paying premiums, and we'd be enormously more profitable. So they charged Folletti and Anda with coming up with ways to help people lose weight. And it turns out they failed miserably. And so they began to ask questions. And the questions they began to ask their patients began to reveal a pattern that they came to identify as adverse childhood experiences. And essentially, from 17,400 patients, what they discovered is that they all had 3 or more of 10 experiences that were contributing, that were correlated with their inability, first of all, with their obesity, and then also with their inability to lose weight. So here are the 10. I've depicted them here on this network to show you how these early experiences in childhood evolve and impact the brain's capacity to process energy and information. So you should see them showing up now. So parental separation, divorce, substance abuse in the household, sexual abuse, mental illness in the household, criminal activity, domestic violence, physical abuse, emotional neglect, or physical neglect, right? And so if you look at all these adverse experiences, what you see them depicted is how they have profoundly impacted the network. And I was actually someone who grew up in a household with all 10 of these. So when I found this research, it made total sense to me. It's like, wow, I really have a damaged brain. So that was the bad news. The good news is because the brain is enormously plastic and flexible, me learning how my brain works has made it work enormously better. And I hope it will do that for all of you. Okay, so if we look at those stars, all those bursts that I put in the slide 24, showing how they compromise the network, if we actually look at a electron microscopic picture of the brain, what we discover is how those dissociation capsules, as which neurologists call them, actually operate and get there. And the way they get there is by having these things called inhibitor neurons, depicted here in this slide 25 as the white cells wrapping around the pink ones. And remember I mentioned in the animation video that sometimes electrons come down, or axons come down and fire electrons that shut off cells. Well, this is what it actually looks like in the brain. And so when we have an adverse childhood experience, we generally tend to experience it as being overwhelming, and our immature neural network is unable to deal with it, and so the brain has to deal with it. And how the brain gets the signal that it has to deal with it is because our body becomes flooded with stress hormones, mostly adrenaline, generating the fight, flight impulse, and then cortisol trying to regulate and calm us back down. Okay? But if the stress is ongoing, then the brain has to go to work, and it has to actually do things to modulate and regulate its functioning. And the way it does it is through these inhibitor neurons. And so I've written out the theory in a nutshell, but how it relates to narrative medicine and how it relates to creative writing is that these neurons in our brain that have been shut off as a consequence of both trauma that may have happened to us before birth, before we acquired language, or subsequently, still live in our networks. Right? All of us, none of us escaped childhood unscathed. All of us have memories buried somewhere of overwhelming things that happened to us. In some other slides, I have pictures of...
Can I jump in here, Mark? Question.
Yeah.
These inhibitory neurons are just inhibiting memory. Is that the essential thing?
No, they're inhibiting action potentials. They're keeping these neurons from firing.
Okay.
So we can give you a simple example. I have a picture on other slides of a little boy getting his first haircut, right? And he's sitting in the barber chairs, and he's in tears because it's overwhelming to him. And here's the important part of this presentation and the example I'm giving you in terms of the barber's chair. He's unable to move the body.
Mm-hmm.
Remember the cerebellum and how many of the brain's neurons are devoted to physical movement? The reason I was traumatized in the 7th grade is because I just sat in the seat and didn't move. If I had had a coach or somebody available to tell me, you don't have to sit there and take that, right? I would have stood up and I would have told that teacher, but I was just a kid, so it's really hard for kids to do that. I would have told them that it's really not good to shame people because they can't perform in your class.
Yeah.
Right? And I would have walked out probably and asked to be reassigned. Right? But you're a kid and you don't know that that's important to do.
Mm.
And your brain pays the consequences. Your brain pays the consequences whenever.
But that's where the inhibitory neurons then get laid in there around the track of that experience or that memory.
Exactly. You got it.
Yeah.
You got it. So what makes trauma, what makes extreme trauma significantly disruptive and disorganizing to the brain is when it happens and you're unable to move your body, right? And we have all kinds of experiences in early childhood especially. I mean, just sitting in a classroom all day long in desks in rows is damaging to the brain.
This is also the source of a lot of medical trauma where people are immobilized while having a, scary medical procedure.
Right. Right. Yeah, people come out of general anesthesia and often they'll go into this extreme violent shaking because they're trying to discharge the freeze response. And it often freaks out medical and nursing staff, and they immediately try to calm you down. Right? I remember the first time I ever experienced this, I was in a motorcycle crash. And fortunately, I wasn't seriously injured, and I got up and I walked over to the street corner, and I just stood there, and my body was just shaking uncontrollably.
Mm-hmm.
Because just prior to the crash, I realized I was going to be in the crash. My body tensed up. It flooded my system with adrenaline, more than I probably ever experienced in my whole life. And when the accident was over and I was able to stand up, then it needed to discharge from the system. If I hadn't been able to do that shaking piece, I would never have been able to probably even drive in a car again because it would just generate too much anxiety.
And then an experience like that would part of the body's response would be to lay down inhibitory neurons to contain that, or that may be the right word, but
right.
That's in the ballpark there.
Yeah, exactly. So if you can't discharge the freeze response, you end up with the brain taking these emergency actions, repressing the memory in what's called dissociative capsules. Okay? So we all have these in our brains, right? Depending on the childhood we had and the severity of the overwhelming experiences we had. So inhibitor neurons and neurons in general are limited in terms of their numbers, right? They're not infinite. They're really finite quantities of them. So if you're a kid who grew up in a really disorganized household and you have tons of traumatic experiences that haven't been sufficiently processed, your brain is basically putting all your inhibitory neurons to work. So what's the result of that? Well, the result of that is you have fewer available resources to regulate behaviors and experiences that would make you open to novelty and exploring the world because you can't self-regulate easily. A simple example for me is when I think about like the possibility of John going on a trip with you to some foreign country,
mm-hmm.
It's totally overwhelming,
mm-hmm.
right? It's like,
and then therein would lie the power. If you were able to choose, and if I was able to, everything goes well, you have an experience not a statement, but it's a question, you'd have an experience that would loosen. That's what I'm curious. What happens to these neurons? Do they get released? Do they go away? They just get less active?
No, what happens? Okay, so if I was to go on a trip with you, there's a high probability that I would become dissociated. And the way that would show up is I'd withdraw. I wouldn't want to go on any of the planned activities. What I would be doing is sitting in my room, and all these kinds of traumatic memories would be surfacing. Now, if I was able to use creative writing and narrative medicine, I could be journaling about these, and as these memories are firing, as they're becoming alive in my brain, I'd be journaling about them, and I'd be moving my body in ways that I wasn't able to move at the time of the original trauma. Does that make sense? Because if you can move your body when you're originally, like if the little boy sitting in the barber's chair could have just jumped out of the chair and run out the door, it never would have been retained. You wouldn't have had to use inhibitor neurons to retain that memory.
Yeah.
They'd be available for other things. He'd be one of the guys. Go ahead.
Yeah, well, as person would write or whatever, do you know what happens to the neurons? Do we know?
Yeah, they stop wrapping around these particular neurons, and they become available as a resource for you to manage and regulate other experiences if you need to. Right? So think of it this way. So you have, it's estimated that roughly 30% of the brain is inhibitor neurons. If they're all used up holding traumatic experiences in place, then you don't have them available for other functions, to deal with other overwhelming experiences.
What was the percentage you just said?
If they're all 30% is the
30%.
Yeah.
Wow.
70% are excitatory, 30% are inhibitory. So part of what makes, here's an interesting observation I've made. People who tend to, this is a gross generalization, so I'm sure there are lots of examples of where it's not true, but people who tend to enroll in the military often have traumatic early histories, right? And I think that the ones who are most susceptible to being affected by post-traumatic stress disorder are the ones who already have extensive traumatic histories. And then they go into these situations where they're being overwhelmed again, and they don't have the resources available in terms of numbers of inhibitor neurons to be able to function. And they end up doing crazy things like massacring people because their brains don't work. I'm thinking of the My Lai massacre in Vietnam and the one that recently happened with a soldier here in Seattle. Right? I guarantee you his brain was not functioning properly. Yeah. So this is the theory in a nutshell. And so creative writing as narrative medicine, this is the topic we're coming back to it. If we begin to be able to use creative writing to access memories that have been walled off by inhibitor neurons and release them, then we have these neural resources available to us to now increase the flow of energy and information generally in the brain. Let's go to 26. What does your body want your brain to write about? So my experience is that it wants me to write about things that make my brain and body, feel good. And we actually know how that works in the brain. Right? We've traced the circuitry. So in this slide, what we see are the circuits and the places where they connect. Glutamate is the excitatory neurotransmitter. This is the one that makes action potentials fire. That's in green. GABA, which is gamma aminobutyric acid, is the inhibitory neurotransmitter. This is what we have 30% of in our brain. And these make neurons not fire. And then dopamine is what makes us feel really good. So if you look at this slide, what you see is the inhibitory neurons firing to stop the flow so that it can allow the dopamine neurons, dopaminergic neurons, to fire, and that's what ends up making us feel good. Otherwise, we feel good all the time, which some drugs are designed to do, right? So does this slide make sense? When I'm writing about things that I'm excited and I get this burst of dopamine that just makes me feel, wow, this is, and oftentimes I'll come back to a piece of writing and I'll read it and I'll say, wow, I wrote that. I'm really a good writer. And what's happening in my brain is actually these dopamine circuitries releasing dopamine in response to the stimulus, which is reading a piece of writing that catches me by surprise that I wrote. All right. So moving along, what does your brain and your body want what does your body want your brain to write about? Things that make your brain and body feel bad. Okay, so how does that work? So on slide 28, I wrote, for creative writing to realize the potential to become narrative medicine, 3 things need to happen. The first 2 involve, so Beth or John, do you recognize this lady?
Well, I think I perused through your slides and made the connection. But no, otherwise I would not have.
Okay, so this is Natalie Goldberg.
Flyer and Virginia Satir, but who is it?
It's Natalie Goldberg.
Okay.
So Natalie Goldberg, longtime meditation student and teacher, and she wrote a book called Writing Down the Bones, and it happened to come out at a time when I had the ability to go hang out with her, and I did. If you read the piece I wrote about that experience, so basically I came away from the week I spent with her with these 2 directives, and they were, give yourself permission to write the worst crap in the world and write about what most disturbs you. And then I asked the question, is that good advice? Well, it turns out that giving yourself permission to write the worst crap in the world really does actually free you up to actually do writing, right? To actually sit down and make your motor neurons move your hands in combination with thoughts going through your brain. All right, write about what most disturbs you, I discovered through actually doing that process, was that when you give yourself and your brain and your body permission to explore and write about what disturbs you, it begins to have a field day with it. Because you're signaling it that you're ready to actually do the work of trying to heal traumatic childhood memories. And it begins to surface these memories over and over again, in the hopes and expectation that integration will happen. Integration being inhibitor neurons no longer having to repress the traumatic memories, that they can be activated. And here's the important piece that Natalie didn't realize and come up with, and the important piece that will make it good advice. We need to be able to move the body in response to our writing in ways we couldn't at the time of our traumatic experiences. Let me say that again. So if we're going to use and do writing as narrative medicine, and we're going to give ourselves permission to write the worst crap in the world and write about what most disturbs us, we're going to surface traumatic memories. And usually what makes a memory traumatic is the fact that when it happened, we couldn't move our bodies. So if we're someone who's been the unfortunate person that experienced being raped, okay? Well, we were unable to move our body. We were unable to take effective action in response to this incident. And so it's living in us and needs to find a way to be healed through integrated discharge. So there are these programs that have been developed that to some extent have been effective, where women who've suffered rape participate and get to be trained to deal with an attacker. And the attacker is a real person who's dressed up in, protective clothing. And in essence, what happens is they reenact their rape, but this time they emerge triumphant. And that process seems to help resolve the traumatic memory. There are less violent ways to do it as well. And a lot of somatic psychology processes have been developed to begin to try to effectively do this integration work. Slide 29. We find ourselves embedded in cultures that are mismatched with our neuroanatomy, neurobiology, and basic instincts. One has only to watch the nightly news to see the myriad ways in which human beings struggle and often fail to cope with this mismatch. In one way or another, we're all like little Crocodile Dundee, a little like Crocodile Dundee in the big city. We're 5-year-olds on our first day of school. And so what Cossolino's pointing to here is the fact that so often our early childhood traumas drive our way of operating in the world, unconsciously. So I'm asking this question on this slide. Which of these two types of neurons, impoverished or enriched, will correlate with better health? These are actually hand-drawn by the father of neuroscience, Santiago Ramon y Cajal, which was a Spanish neuroscientist. And he looked at these under a microscope, and he was astonished to find these different degrees of richness in terms of growth, much like plants. So what makes neurons enriched is something called brain-derived neurotrophic factor, BDNF, and trauma reduces the amount and deployment of BNF, of trophic factors in the brain. And the result is neurons like those on the left. But the good news is we can put ourselves in situations and circumstances where we can actually produce what look like really healthy vegetables, actually, on the right. And the ones on the right have a tremendously improved capacity to process energy and information. And I would argue that enriched neurons are much better able then to have our immune function operate robustly. Does that make sense? That if you can process, your brain and body can process more energy and information, it would positively impact your immune system.
I'm not sure why that should be so, but it certainly would make sense that good things would happen if we can increase that.
Yeah. Well, let me just briefly tell you my understanding of how it happens. So immune function basically is our ability to deal with pathogens, right? And so how the body tends to deal with most pathogens is that it responds to signals that something's invading, right? Whether it's a virus or it's a group of cells that are beginning to multiply out of control. And so when it gets that signal, the immune system then goes to work and does what it can to remove the threat, okay? The threat could be a virus, or it could be, it could be a splinter that you get in your finger, right? Well, I have had experiences, and this is a good story. I should tell this story. So for many years, I was curious about spiritual communities and how they work. And so one day I worked up the courage to sort of hang out on the periphery of a spiritual community in New York. I was helping out set up a picnic, and in the course of helping out, I picked up this Formica table, and the bottom leaf dropped out, and it fell down on my toe, and basically almost severed it. Popped the nail off, blood everywhere, enormous pain. I continued to help out, and when the picnic was over, the people who helped with the picnic were invited to come up to the front of the group and to receive a blessing from this guru. Well, I was kind of ambivalent about it, but I was encouraged by my friends to do it, and so I went up and kneeled down. He puts his hands on your head, and great. I didn't feel anything, nothing special. Went home that night. Woke up the next morning, the pain is totally gone from my toe, and the nail has completely grown back overnight. That was astonishing to me. And what I suspect, and this is how people I suspect this is also how healers like John of God and, other faith healers, when they're successful, how they work, is that he had temporarily managed to connect up the fibers in my brain and in my immune system in ways that accelerated the healing process enormously and subtly, because I think these energies really are subtle. And so if we looked at slide 30, also, I just want to mention here, there's a study that was done by the Institute for Noetic Sciences, where they went out and they obtained 3,500 accounts from people who had spontaneously healed from serious illness, that medical science had no explanation for how it happened. Well, I think we're beginning to understand how it actually does happen. And I think it primarily happens by us doing something that increases the flow of energy and information in our brains. So on slide 30, I put in these two depictions. And for me, just through this depiction, my intuition would be that, the more integrated brain is able to process more energy and information, but it matches my experience. Let's see, slide 31. For creative writing to realize the potential to become narrow in medicine, 3 things need to happen, and the third thing is crucial. And so we already touched on this, but I really want to repeat it here, because this is what Styron didn't do, that in my estimation is responsible or correlates with his ending up with this suicidal depression. With neurons firing action potentials, surfacing memories of adverse childhood experiences. So in other words, inhibitor neurons have momentarily released, and all it takes is one little thread of a neuron. Like you can have this, just a smell associated with a trauma can begin to then cause the whole capsule to kindle. There's this phenomenon in traumatology called kindling, where now the whole constellation is firing and the whole memory is now active, right? When it becomes active, we need to be able to move our body in ways we were unable to at the time of the trauma and successfully discharge the freeze response in ways that result in something that feels to the body like triumphant action. All right? And I have this link. Links don't really play on this platform very well, but it's the scene, I would encourage you all to watch it. It's the diner scene from the Jack Nicholson movie, 5 Easy Pieces. And that's a memorable scene for me for a number of reasons. And I can only imagine how enormously pleasure-giving it was for the writers when they wrote it, and also how great it was for Jack Nicholson to be able to act in it. It's the scene where he basically, can't get a side order of toast, and he ends up just completely moving his body in ways that release this frustration and anger, at this stupid policy that the restaurant happened to have, right? Well, he didn't end up traumatized by that action, by that experience. The waitress, however, in that movie, I would predict probably did, because she was helpless. And she was unable to do anything in response to his actions. All right? So this is the key. Triumphant action. The thing we couldn't do at the time the trauma happened, the ways we weren't able to move our body, to be able to move them while the neurons holding that memory are firing and they're active.
Mark, are you talking about that being part of the writing process itself?
Absolutely. So here's how it worked for me.
Mm-hmm.
I write a scene, and it's clearly a scene from my childhood. This one happened to be a basketball scene where two guys were basically jumped me on the basketball court, started beating me up, right? And they overwhelmed me. So when I wrote the scene in The Icing of the Shooter, basically what I had was me emerging triumphant, being able to actually overcome these guys. And then I actually went out and actually went to a basketball court and did the movements on the court that I wrote about.
And Mark, what about emotion? Can you talk about emotion during the process, the feeling of the emotion in addition to the movement of the body?
Yeah. So the whole time I'm on the basketball court doing these motions, and also while I'm writing the scene, I'm in tears. I'm just overwhelmed because the memory is really active. I'm no longer, in the present moment. I'm dissociated. I'm back in, the Brookside housing projects, and I'm on the basketball court, and here's these two bullies just, terrifying me. But now, I'm rewriting history. I'm rewriting history, and I'm rewiring my neurobiology. And so when I go out onto the basketball court and begin to make these movements, I'm also feeling this welling up of anger and frustration and actually a big piece of it was sadness. There's a lot of sadness, both for me as a little kid then who had this experience, but then also needing to then take it out on these other guys because, bullies are only bullies because they've been bullied. This is a disorganized response to their own environment. Does that answer the question, Beth?
Yeah, I just wanted to understand that the movement isn't just physical. It's helping maybe an emotion to be felt as well.
Absolutely. Yeah, that's what makes narrative medicine, creative writing as narrative medicine so difficult, because you need to be willing to feel lots of feelings that don't feel good. But you need to be able to feel them in the service of integrating and healing them. I mean, that's why psychotherapy works when it works, because people are able to actually feel what they feel, but not just feel it, because you don't want to reenact stuff and not resolve it, because that just adds one more level of trauma, to your history. You want to resolve it. You want to be able to move it, through the process of integration, meaning free up inhibitor neurons holding these memories in place, dissolving dissociation capsules. So slide 32 I thought was really interesting, because what it says is that physical aggression is the most frequently reported theme in nightmares, right? So you see in this picture I have, you see someone like being frozen in response to this attack, right? Well, from my perspective, what the brain's trying to do is to find a way to actually take action in response to this attack, which would represent integration. And when I took dream classes in graduate school, what the professor would always have us do is then act out whatever the dream sequence was, but always end it in some way that physically represented triumphant action. Because just surfacing these memories over and over again without actually moving the body to resolve them doesn't heal them, doesn't result in integration. Okay, so we're coming to the end here, and here's an image I want to leave you with. How might writing work to cure cancer? The healing power of the coherent narrative. So, in part, this is based on reading and research, but it's also in part based on my own personal experience. And that is, as I have gone through tons of programs and therapies and pursuits in the service of healing, what my experience has been is gradually I've become increasingly able to operate in the world with a network that operates better and better and better, even though I identify myself as someone who experienced all these early adverse childhood experiences. So I'm guessing my brain isn't completely devoid of dissociative experiences, but it's clearly a lot cleaner and emptier than it ever has been. And the work will continue for me, going forward. All right? And so ideally, this is the image that I really like. Here's the network. This is the network that the best of us were born into. This is how our brains unfolded early childhood. All right. So I've got some resources here that I really encourage people to take a look at. So this one, Jane Wheatley Crosby's, is actually an article on the internet. So if you click on this, you'll see the link to it. She's talking about how healing happens, much as I've described to you in this presentation. Another one is Robin Carr Morris and Meredith Wiley's Scared Sick. And again, they go into this in great depth, how these early experiences adversely affect our neurophysiology. And then finally, Bob's book, Bob's calls himself a recovering neurologist. And I have a lot of respect for him. One is because he's used his own brain and body as a observation post to do his research and to do his writing. And so the first edition of this book, The Body Bears a Burden, suffered enormously from what's called the curse of knowledge. And what the curse of knowledge is basically someone who's really steeped in a field of expertise really forgets how those of us who aren't steeped in it don't understand what the hell he's talking about. But he's been great. So he took that feedback and he rewrote the whole book for a second edition. And now he's come and he's rewritten it again to make it even try to be more understandable to lay people for the third edition. So this is the healing piece, and the next one is the writing piece. All right. Slide 35 is the writing piece. So here's a book edited by Meredith Moran, who essentially interviewed all these writers, or took writings from them about their writing process. And what you see, if you look at it through a neuroscience healing lens, is that many of these writers are actually writing to try to help heal their own personal history. And then Natalie Goldberg's newest book, True Secret of Writing. And then finally, Rita Sharon's book that she based her program in narrative medicine on at Columbia, just honoring the stories of illness. All right. So finally, I'm working on chapter 2 for those of you who might be interested. And there's some of the questions I'll be asking them in that session. And now we're at the end. Any final questions?
Just a quick request, Mark. I tried to click on the link for the article, Healing Traumatic Reenactment, and at least on both on the PowerPoint and on the GoToMeeting, it doesn't seem to work. So maybe you can send that link out.
Okay. Yeah.
It's just a glitch I'm having.
Well, it has to be in play mode if you're on a Mac, or in Keynote, or it has to be in full screen mode for the link to work. Let me go back to it, see if it'll work for me. This one?
Hang on. Yes.
Oh. Okay. So I'll get you the link and I'll send it out to everybody. I'll make a note right now. Great. All right. Anything else? Okay. Well, we're at an end here. I hope it's been useful. I hope it's been something that you're able to actually take and apply in the world, in your personal life, in your work life. And I'm totally open to hearing from people and asking me any questions you want to ask me. To talk one-on-one on the phone. To explore these things further. I mean, this is just something that I have found to be so useful and helpful for me, that I'm really passionate about indoctrinating all of you. All righty then. So why don't we end here? And I thank you all for showing up and participating, and we'll be in touch going forward.
Yeah, thank you, Mark.
Yeah.
A lot of great material here. I really appreciate the work you put into this.
Thanks, John.
Yeah, same here. I echo that statement that John made, Mark. A lot of information. Certainly, it'll take me some time to process it.
Well, life has a way of inviting us to process and integration.
Yeah, I look forward to it.
Okay. Take care, everyone.
Take care.
Until next time. Bye.
Yep. Bye now.